Welcome to another deep dive, this time into the mysteries of space exploration
Oh, yeah.
and the search for extraterrestrial life.
Very cool.
You've shared some really intriguing excerpts from the Korean text. Amgo! Ho do.
Right.
That's space exploration, science, missions, and extraterrestrial life for everyone out there.
Yeah.
And, astronaut life to the physics of black holes and the quest for alien signals.
Really runs the gamut.
Yeah, it really does.
It's a captivating blend of science and human interest stories.
Yeah, for sure.
I think there's some real surprises in here for you.
Okay, well, I'm ready to be surprised.
Right.
Let's start with a story that really caught my eye.
Huh.
The astronaut Roger Crouch, who made it to space,
Oh.
despite being colorblind.
Huh.
Now, this was back in the early days of the space program,
Yeah.
when NASA had some pretty strict rules about who could be an astronaut.
Oh, yeah, they did.
So how did Crouch slip through the cracks?
Well, the source material talks about how astronaut selection has evolved over time. Back then, NASA was mainly recruiting test pilots.
Right.
Vision was absolutely paramount.
Surprise.
But Crouch's case really highlights this shift towards scientific expertise. He was a payload specialist, and it really shows how NASA started to prioritize the scientific tasks of a mission.
Yeah, it's incredible how much emphasis is placed on, the scientific tasks of a mission now.
For sure.
It's not just about getting to space, it's what you do when you're there.
Absolutely. And the Korean text mentions the rigorous training that astronauts undergo
Oh, yeah.
to prepare for these demands, both physical and psychological.
Oh, gosh, yeah, I bet.
The challenges of living in, a confined multicultural environment,
Right.
which I thought was really insightful.
What kind of challenges are we talking about?
Well, you're living in a tiny capsule, hurtling through space with people from all different backgrounds and cultures.
Oh, my.
So the text emphasizes mental resilience and teamwork.
Right.
Those soft skills are essential in that kind of high-pressure, isolated environment.
Yeah, it makes sense.
For sure.
That's really interesting. It's a reminder that space exploration is as much about human collaboration
Yeah,
as it is about technology.
you got it.
Absolutely. Speaking of fascinating places, let's talk about Ganymede,
Okay.
Jupiter's moon,
Right.
which plays a key role in the source material.
Uh-huh.
It's got this intriguing magnetic field, which suggests,
A molten metallic core,
whoa,
very similar to Earth's,
really?
which has some pretty major implications for Ganymede's potential to harbor life.
Wait, a moon with a molten core like Earth?
It's pretty amazing.
That's mind-blowing.
Yeah.
What does the Korean text say about the possibility of life on Ganymede?
Well, they explore the idea that a molten core could generate internal heat,
Right.
potentially creating conditions suitable for life
Mm.
beneath Ganymede's icy surface.
Wow.
It even mentions the possibility of hydrothermal vents,
Yeah.
which we know support these unique ecosystems here on Earth.
Hydrothermal vents on a moon.
Isn't that wild?
Okay, now I'm really hooked.
All right.
So we're talking about the potential for life, not just on other planets, but on moons, too.
Exactly.
This expands the possibilities even further.
It really does. And it ties into this discussion of biomarkers
Oh, right.
that the source material has.
Okay.
You know how scientists are looking for biomarkers in exoplanet atmospheres?
Yeah.
Telltale signs of biological activity.
I've heard about biomarkers, but I'm a little fuzzy on the specifics.
No problem.
What kind of things are we talking about?
Well, think of them as chemical fingerprints of life,
Okay.
like methane, oxygen,
Oh.
even complex organic molecules.
Right.
These wouldn't exist in an atmosphere in significant quantities, at least,
Right.
without some kind of biological process creating them.
So if we find these biomarkers on a distant planet,
Yeah.
it's a strong indication that something might be living there.
It's definitely a major clue. But of course, it's not foolproof.
Yeah.
There might be non-biological explanations for some biomarkers.
Sure.
So scientists have to be cautious. It's a bit like a detective, searching for clues.
Right.
Each biomarker adds another piece to the puzzle.
That's fascinating.
Yeah.
And it makes me think about Oumuamua, that interstellar object
Oh, yeah.
that flew through our solar system a few years back.
Right.
The Korean text touches on how its strange trajectory and shape sparked a lot of debate about its origins.
Yeah, some scientists even considered the possibility that it was an alien probe.
I remember that.
It was really something.
I mean, was that a serious theory or just speculation.
Well, Oumuamua was definitely a puzzle.
Yeah.
The alien probe theory, I think it's fair to say, is highly speculative.
Okay.
But its discovery really underlined how little we know about the vastness of space and the strange objects it might hold.
It's true, yeah.
It was a reminder that the universe is full of surprises.
Speaking of surprises, I've always wondered about the practicalities of space travel.
Yeah.
Like, how long would it take to reach Jupiter with our current technology?
That's a great question, and the answer really depends on the mission's goals.
Oh, okay.
A flyby mission, like New Horizons' journey to Pluto, could reach Jupiter in about a year.
Wow.
But if you want to enter orbit around Jupiter, it takes considerably longer.
So we're talking years to actually get into orbit.
Yeah, you're looking at maybe 5 or 6 years.
Why the big difference?
Well, orbital insertion requires a lot more precision.
Oh, okay.
You need to slow down enough to be captured by Jupiter's gravity.
I see.
Which adds significant time to the journey. The text cites the Juno mission, which took about 5 years to reach Jupiter and settle into orbit.
That's credible. It makes you appreciate the level of planning and calculation
For sure.
involved in these interplanetary missions.
Absolutely. Tons of planning.
And it brings us to another topic that's often debated. The Apollo moon landings.
Right.
The Korean text explores the enduring fascination with these missions.
Yeah.
And asks why we haven't returned to the moon in over 50 years.
Big question.
Yeah, that's something I've always wondered about. Why haven't we gone back?
Well, the text kind of delves into the historical context of the Apollo program,
Go ahead.
highlighting its roots in the Cold War.
Oh, right.
You know, it was a race for technological supremacy, more about national pride and political posturing than pure scientific exploration.
So the lack of scientific focus might have contributed to the decision to abandon lunar exploration.
I think it's definitely a factor. However, there is this renewed interest in lunar exploration today.
Oh, yeah.
Particularly with the Artemis program.
Right.
Which aims to establish a sustainable presence on the moon.
I've heard about Artemis. Is it true that China's growing space program is a motivating factor for these new lunar missions?
The text suggests that China's ambitions in space have definitely played a role in reigniting global interest in lunar exploration.
I see.
It seems that the spirit of competition is alive and well, even in the 21st century.
Yeah, for sure.
But this time around, the focus is shifting, I think.
Okay.
Towards international collaboration and long-term scientific goals.
It's fascinating how these motivations for space exploration have evolved over time.
For sure.
Okay, I want to talk about something that always blows my mind. Time dilation.
Oh, yeah, that's a good word.
The Korean text uses this example
of
a father traveling in space while his daughter ages on Earth. Is it really true that time is relative?
It is. It really is one of those concepts that really challenges our everyday understanding of the universe.
It does.
Time is affected by gravity, meaning it passes at slightly different rates depending on where you are and how fast you're moving.
I remember learning about this in school, but I never quite grasped how it works.
It's tricky.
Yeah.
Think of it this way. Imagine a clock at sea level.
Okay.
And another clock on top of Mount Everest, because gravity is slightly weaker at higher altitudes.
Right.
Time would actually pass a tiny bit faster.
Oh, wow.
For the clock on the mountain.
Really?
Of course, the difference is incredibly small.
Yeah.
But it demonstrates how gravity can warp time.
So theoretically, if that astronaut father was traveling at incredibly high speeds or near a strong gravitational field, he could return to Earth younger than his daughter.
That's the idea.
It sounds like science fiction.
It really does, and it just highlights how even our most fundamental understanding of reality can be challenged by the laws of physics.
That's amazing. Speaking of mind-blowing concepts,
Okay.
let's dive into the search for extraterrestrial intelligence. SETI.
Right.
The Korean text tells the story of Frank Drake and his early work in this field.
Yeah, he's a real pioneer.
I mean, he actually thought he detected alien signals from the Pleiades star cluster at one point.
He did. It's a great story. It's really a captivating blend of scientific ingenuity and human fallibility.
Right.
Those initial signals turned out to be interference.
Oh, wow.
Yeah, but his work really paved the way for decades of SETI research.
What was Drake's rationale for focusing on radio waves as a potential communication channel for alien civilizations?
Well, he reasoned that advanced civilizations would be aware of the 21-centimeter hydrogen line. This specific radio frequency emitted by neutral hydrogen atoms, it's the most abundant element in the universe.
Right.
And its signal can penetrate dust clouds and other interstellar obstacles that might block visible light.
So he figured any technologically sophisticated civilization would understand the significance of this hydrogen line and potentially use it as a universal beacon.
That was his thinking, and it led to the launch of Project Ozma in 1960.
Oh, wow.
The first modern SETI experiment. Although Project Ozma didn't find any conclusive evidence of alien signals, it sparked decades of research and inspired countless scientists to continue the search.
And now we have AI-powered initiatives like Breakthrough Listen.
That's right.
Sifting through mountains of data with unprecedented speed and precision.
It's really incredible.
It feels like we're entering a new era in the quest to answer that age-old question. Are we alone in the universe?
Absolutely. And while we haven't found definitive proof yet, the search itself has yielded incredible discoveries and pushed the boundaries of our technological capabilities.
It's truly a testament to human curiosity and our desire to understand our place in the cosmos.
Couldn't have said it better myself.
This has been really fascinating, and I think we're just scratching the surface here.
Oh, yeah, we've got a lot more to cover.
I'm ready for more.
All right, let's do it. So, one of the things that really struck me in these excerpts was this discussion about how different planets have different lengths of day.
Oh, yeah. It's easy to forget that our 24-hour cycle is just a quirk of Earth's rotation.
Exactly. The source material actually points out that a day on a planet is determined by its rotation period. So, on some planets, a day could be shorter than ours, while on others, it could be much longer.
They even mention planets that are tidally locked to their stars.
Oh, wow.
Always showing the same face, just like our moon does with Earth.
Right.
Can you imagine living on a planet with one side in perpetual daylight?
Oh, God.
And the other in eternal night?
It's mind-boggling. The text highlights that for those planets a day essentially equals a year.
A year-long day.
Yeah, it makes you reconsider our whole concept of time, doesn't it?
It really does. It would certainly change things.
Yeah.
But let's get back to SETI for a moment.
Okay.
The Korean text brings up a question that I've always found puzzling.
All right.
Why search for alien signals using radio waves when light travels faster? Shouldn't we be using the fastest method possible to communicate across vast cosmic distances?
It's a common misconception that light is always the fastest way to transmit information. While it's true that light travels faster than radio waves in a vacuum, radio waves have certain advantages when it comes to interstellar communication.
What kind of advantages?
Well, for one, radio waves can penetrate dust clouds and other interstellar obstacles that would block or scatter light waves. They also experience less attenuation, meaning their signal strength doesn't weaken as much over vast distances.
So even though radio waves travel slower, they might actually be more reliable.
Exactly.
Long-range communication.
Yeah. And there's another intriguing factor. Humanity has been unintentionally broadcasting radio waves into space for over a century.
Oh, that's right.
So if there are any civilizations within that 100 light-year radius with technology similar to ours, they might just be picking up our old TV shows and radio broadcasts.
Wow. So some alien civilization might be tuning into classic Earth sitcoms right now.
It's possible.
That's both hilarious and a little bit unsettling.
Yeah.
But it raises an interesting question. If we could use something other than light or radio waves to communicate across the cosmos, what might that be?
That's where things get really interesting.
Okay.
The Korean text hints at the potential of gravitational waves for astronomy. They can travel unimpeded through matter, giving us a glimpse of events and objects that are hidden from traditional telescopes.
Gravitational waves, those ripples in space-time caused by massive objects.
Yes, exactly.
I remember when their detection was first announced, it was a huge scientific breakthrough.
It really was.
But could we actually use them to communicate?
It's a fascinating possibility.
Yeah.
Although the technology to create and detect gravitational waves with enough precision for communication is still far beyond our current capability.
Of course, yeah.
It would require manipulating incredibly massive objects, like black holes, which is a daunting prospect, to say the least.
Mind-boggling to think that we might one day be using the very fabric of space-time.
I know, it's amazing.
To send messages across the galaxy?
Yeah.
It would be like weaving signals into the universe itself.
It's a beautiful thought.
Okay, let's shift gears a bit and talk about the human side of space exploration.
Right.
We touched on the physical and mental challenges of living in space.
Yeah.
But I've always wondered how astronauts cope with the lack of gravity.
It's a significant adjustment, for sure.
Right.
The source material describes how microgravity affects everything.
Wow.
From basic bodily functions to simple tasks we take for granted on Earth.
I can imagine. Just trying to eat or drink in a weightless environment.
Yeah.
Must be a challenge.
Absolutely. The text describes how astronauts have to eat specially prepared food
Right.
that won't crumble and float away.
Makes sense.
And they also have to drink from pouches with straws.
Oh, wow.
To prevent liquids from forming messy spheres.
No more casual spills or crumbs allowed.
Exactly.
What about sleeping?
Yeah.
Do they have to strap themselves down so they don't drift around the cabin?
They do. They sleep in these special sleeping bags that are secured to the walls.
Wow.
And they have to be careful about personal hygiene because even brushing your teeth can create a cloud of toothpaste particles.
Oh, gosh. It all sounds very challenging.
It is.
But I imagine there's also a certain sense of freedom and wonder
Oh, for sure.
that comes with experiencing weightlessness.
Absolutely. The Korean text describes how astronauts often experience what's called the overview effect.
Oh, yeah, I've heard of that.
This profound shift in perspective that comes from seeing Earth
Yeah,
as a fragile blue sphere floating in the vastness of space.
I bet that changes you.
Yeah, it really does.
That's like that famous quote from astronaut Edgar Mitchell.
Oh, yeah.
You develop an instant global consciousness, a people orientation, an intense dissatisfaction with the state of the world, and a compulsion to do something about it. From out there on the moon, international politics looks so petty. You want to grab a politician by the scruff of the neck and drag him 250,000 miles out and say, "Look at that, you son of a bitch."
Wow, that's powerful.
It really is.
It's a humbling experience.
Yeah.
It highlights the interconnectedness of all life on Earth,
Right.
and it emphasizes the importance of international collaboration.
Which is a perfect segue to our next topic.
Yeah.
The role of international cooperation in space exploration.
All right, good timing.
We've talked about the competitive side of things,
Yeah.
but the source material really underscores the importance of nations working together.
It does. The text actually uses the International Space Station
Okay.
as a prime example of successful international collaboration.
Yeah.
It's a testament to what we can achieve when we pool our resources and expertise towards a common goal.
It's like a microcosm of Earth and space.
Right.
With astronauts from different countries living and working together
Yeah,
for months on end.
for sure.
It's a powerful symbol of unity and cooperation.
Precisely. And it's a model for future space exploration. You know, as we venture further out into the cosmos,
Yeah.
international collaboration will be essential to overcoming the immense challenges and costs associated with these ambitious missions.
It's like a giant cosmic jigsaw puzzle.
I like that.
And each nation holds a unique piece
Right.
that's essential to completing the picture.
Good analogy.
Now, I want to delve into a topic that's always fascinated me, the concept of space as a frontier.
Okay.
The Korean text talks about how space exploration can drive technological innovation
Uh-huh.
and inspire new generations of scientists and engineers.
It's absolutely true. Space exploration is a powerful engine for innovation. It pushes the boundaries of what's technologically possible,
Right.
leading to advancements in materials, science, robotics, propulsion systems, and countless other fields.
It's like the Wild West of the 21st century.
That's a good way to put it.
A vast, unexplored territory ripe for discovery and innovation.
Exactly. And it's not just about the practical applications.
Yeah.
Space exploration also has the power to inspire
Right.
images of astronauts walking on the moon, robots exploring Mars, telescopes peering into the depths of the cosmos.
Yeah.
They all ignite our imagination
They do.
and encourage us to dream big.
It's that sense of wonder and possibility that keeps us reaching for the stars, isn't it?
I think so.
It's a reminder that there's so much more out there to discover.
Absolutely. And as we continue to explore,
Yeah.
we're constantly challenged to expand our understanding of the universe and our place within it.
For sure.
It's a humbling and exhilarating journey.
It really is.
You know, it's amazing to think about how far we've come in our understanding of the universe.
Yeah.
We've gone from believing Earth was the center of everything
Right.
to realizing it's just one tiny planet,
Uh-huh.
orbiting an average star in a vast, ever-expanding cosmos.
It really is humbling. And
Yeah.
it makes you wonder what other, paradigm-shifting discoveries
Right.
await us
Exactly.
as we continue to explore. I mean, we're still grappling with concepts like dark
Yeah.
matter and dark energy.
Yeah.
These mysterious entities that make up the vast majority of the universe,
Right.
but which we can't even see or directly detect.
It's a stark reminder of how much we still don't know.
Yeah, it really is.
Dark matter and dark energy are like these invisible forces shaping the universe, and we're only just beginning to understand their influence.
Yeah.
It's a testament to the enduring power of scientific inquiry.
It really is. It's like we're piecing together a giant cosmic puzzle.
I like that analogy.
And we've only found a few of the pieces.
Yeah, just a few.
But speaking of mind-boggling concepts, the Korean text touches on something that's truly out there.
Oh, yeah. What's that?
The possibility of multiple universes.
The multiverse.
Yeah.
The idea that our universe might be just one of countless others existing alongside ours.
It sounds like science fiction.
It does. It does. But it's a concept that has gained some traction in theoretical physics.
Okay, I have to admit, the idea of a multiverse is a bit hard to wrap my head around.
I hear you.
Are we talking about parallel universes, alternate realities, or something else entirely?
Well, there are different theories about what a multiverse might look like. Some suggest that there are infinite universes branching off from every quantum event, creating this vast network of parallel realities.
Oh, how?
Others propose the existence of bubble universes, separate self-contained universes that exist within a larger multiverse structure.
So there could be other universes out there with different laws of physics.
Potentially.
Different constants, maybe even different versions of ourselves.
It's a mind-bending possibility.
It really is.
And while we don't have any direct evidence to prove or disprove the existence of a multiverse, it's a concept that sparks the imagination.
It does.
And pushes us to think beyond the limits of our current understanding.
It's a reminder that the universe, or perhaps universes, might hold possibilities.
Yeah.
Far beyond anything we can currently comprehend.
It's pretty awe-inspiring.
It really is. It's enough to make your head spin.
For sure.
But let's bring things back down to earth for a moment.
Okay.
We've talked a lot about the scientific and technological aspects of space exploration.
Yeah.
But what about the ethical and philosophical implications?
That's a crucial aspect that deserves careful consideration. As we venture further into the cosmos, we need to grapple with these ethical challenges of exploring new worlds and potentially encountering extraterrestrial life.
It's a huge responsibility.
It is.
What if we encounter a civilization less technologically advanced than ours? How do we interact with them ethically and responsibly?
It's a great question.
And what about the potential for resource exploitation? As we search for new sources of energy and minerals, we need to be mindful of our impact.
For sure.
On these alien environments.
Exactly. The Korean text raises these important questions about the potential consequences of our actions in space. It emphasizes the need for careful planning and ethical guidelines to ensure that our exploration benefits humanity as a whole while respecting the integrity of the cosmos.
It's like the old saying, with great power comes great responsibility.
Yeah, for sure.
We need to approach space exploration with a sense of humility and awareness, recognizing that our actions have far-reaching consequences.
Absolutely. And it's not just about minimizing harm. It's also about fostering a sense of wonder and appreciation for this incredible diversity and beauty of the universe.
Yeah, you're right. It's about preserving the cosmic wilderness for future generations. And ensuring that our exploration is driven by curiosity, respect, and a desire to expand our understanding of our place in the grand scheme of things.
Beautifully said. I think that's a great note to end on. As we wrap up this deep dive into space exploration and the search for alien life, I want to leave our listeners with one final thought. We've covered a lot of ground.
We have.
From the practicalities of space travel to the mind-bending mysteries of the cosmos.
It's been a wild ride.
But I think the most important takeaway is this. The universe is full of wonder and possibility.
It really is. It's a vast, unexplored frontier that beckons us to explore, to discover, and to push the boundaries of human knowledge.
It's true.
So to everyone listening out there, keep looking up, keep asking questions.
Yeah, good advice.
And never lose that sense of awe and curiosity.
Couldn't agree more.
Who knows what incredible discoveries await us just beyond the horizon?
I can't wait to find out.